Now, this is the second part of our video on heat energy, and it will be based on latent heat. Now, what is the meaning of latent heat? From the name, it is what? It's also called hidden heat. That is the type of heat that effect of heat will not show on the thermometer. So, we call it latent heat because during this period, there will be no change in temperature. The heat you are supplying during the period, the material is using it to change from one state to another. Then to define latent heat, you can easily say latent heat is quantity of heat required to change substance from one state to another without changing in temperature. So because of that, we can say we have three types of latent heat. When substance is changing from solid to liquid, we have latent heat of fusion. Then when substance is changing from liquid to gas, we have latent heat of vaporization. Then what of the substance that will change directly from solid to gas? We have latent heat of sublimation. Then if you want to define heat, say latent heat of fusion is quantity of heat required to change from solid to liquid without change in temperature. While latent heat of vaporization is quantity of heat required to change from liquid to gas without change in temperature. Then latent heat of sublimation is the quantity of heat required to change solid directly to gas without change in temperature. Now don't forget, when you have a solid object and you supply heat to it, the first thing is the temperature will first of all increase. The graph will look like this. You can see the graph. Consider at initial state, at heat is increasing, the temperature is also what? Increasing. So you get a state when temperature remains steady. At that period, it does not mean that the heat is not more supplying, but the substance is using it to change from one state to another. The same thing applicable to when you have what? Latent heat of vaporization as well. Now, the next thing is, what are the factors on which latent heat depends on? Like we did in heat energy and heat capacity. So latent heat of a body depends on majorly, let's say, two factors. The first thing is latent heat. Latent heat, see, is heat energy also. Its unit is also what? In joule, because it's energy. So vary directly with what? Mass. The quantity of mass in that particular body. How big the body is. Then, and don't forget that in our mathematics, when you remove this one, you are going to put constant. And constant under this is what? Specific latent heat. Therefore, the energy supply during changing of state depends on latent heat of that state and the quantity of the mass, how big the mass is. When you are calculating, so depend on the stage. Is it from solid to liquid? If it is from solid to liquid, this L will stand for specific latent heat of fusion. But if it's from liquid to gas, this L will stand for specific latent heat of vaporization. But if it is solid directly to gas, this L will be what? Specific latent heat of sublimation. Now, what is the meaning of specific latent heat? We've defined latent heat itself. What of specific latent heat? We have specific latent heat of fusion, specific latent heat of vaporization, and specific latent heat of sublimation. Very simple. In our previous video, I've said it that specific means one. Therefore, specific latent heat alone means the quantity of heat required to change a unit mass of substance from one state to another without change in temperature. But when you are not talking about specific latent heat of fusion, it means the quantity of heat required to change a unit mass of substance from solid state to liquid state without change in temperature. But specific latent heat of vaporization, that would what? Quantity of heat required to change a unit mass of substance from liquid to gas without change in temperature. Then that of specific latent heat of sublimation would what? quantity of heat required to change a unit mass of substance from solid state to gaseous state without change in temperature. Now let's solve one question under the use of latent heat. Now the question says an ice of 50 grams at 0 degrees centigrade was completely melted by 70% of the total heat energy supply. Calculate the total heat energy supply. Now from the question, what and what I give you? They gave us the mass. So mass M is equal to 50 grams. Now, from here, do we need to change the mass to kilogram or not? That's why you need to go and check any constant in your question. The constant, which is specific latent heat of fusion, is 336 joule per gram. So in that case, we don't need to change this one again. So our L is 336 then times joule per gram. Now then says 70%. Now the first thing is, what is the quantity of heat required? So the heat energy required in that case will be energy is equal to ml. Then now said the quantity of heat used, the total heat supply, but the one used there is just 70% of this one. It will now be 70% of this, that is 70 multiplied by 70 over 100 of this energy, E, is equal to ml. So we are looking for this heat supply. Then can cross multiply, therefore 70 E is equal to 100 ml. Then in the question, they gave us M, they gave us L. So therefore this one equal to 100 multiplied by, what is L? 50. Then what is L? L is 336. Then whatever you get, you divide by 70. Therefore, our energy, total energy supply, will be 100 times 50 times 336 divided by 70. Divided by 70. So this cancel this. So total energy will be what? 500 times 336 divided by 7. So whatever you get is your final answer, and it will be in joule because we are calculating energy. So that is that about that. So if you have any question, you are free to call me through the number on the screen.